In this video, we give a brief introduction to basic computations using Mathematica. If you haven't installed and activated Mathematica yet, you should pause and do so first. Mathematica has two parts to it: the kernel and then the front end. The kernel is the computational engine of the software. You should never have to use the kernel directly. Instead, you will want to load Mathematica front end itself. When you do so, it'll bring up the following welcome screen. To the left are recent files that have been used. You may select one of these or start a new file by pressing New Document. This opens a blank file called a notebook. In the lower right-hand corner is an option to change the magnification, which I'm going to do to make it easier to see what is happening. Mathematica is a powerful computational tool. It can do any operation that a calculator can do and a whole lot more. To give it a computation, we enter the computation using standard keyboard commands and shortcuts. As a first example, we will give it a simple problem of 2 plus 2. To indicate to Mathematica that the command is ready to be executed, we have to press the Shift key and the Enter key simultaneously. If we just press Enter, like I've just done, it just moves to a new line. Pressing Shift-Enter instructs Mathematica to do the computation. That first computation can sometimes take a moment or two. This is because the kernel generally has to be loaded, but once that is done, we can get any computation we want. Mathematica uses standard keyboard symbols for mathematical operations. For example, multiplication can be done using an asterisk, or it can be done using a space. Mathematica adds the multiplication symbol on its own. If we want to use powers, we use the caret symbol. And fractions or division are done with a /. So if we wanted to add 2 1/4, we would write 2 plus 1 over 4. Parentheses and only parentheses can be used to group computations. All other delimiters, such as brackets or braces, have other reserved roles. So if you have any sort of complicated computation you wish to do, the only option you have to use to group things are parentheses. Mathematica aims to be as precise as possible and give exact answers whenever it can. For example, if we ask it what 13 divided by 56 is, it will tell us precisely what it is, namely 13 divided by 56. That doesn't tell us much. To get a numerical approximation, we use the capital letter N, standing for number. If we ask it to tell us what the numerical approximation to 13 over 56 is, it'll give it to us. Mathematica can compute all common mathematical functions. Mathematica tries to use intuitive names as much as possible. So, for example, if we want the cosine of an angle, the command is simply COS. All native commands in Mathematica begin with a capital letter. So for cosine, we need to start with a capital C followed by OS. The quantity or variable to which a function is being applied is always placed in square brackets. So if I want the cosine of pi over 3, I tell it I want the cosine of pi divided by 3 using a /, and I put that in square brackets and then hit Shift-Enter. And it'll give me a perfectly good value. Alright, if I wanted a numerical approximation to that, I could then use the N command. Depending on what class you're using Mathematica in, you may have different types of functions that you use, but they all have the same syntax, namely starting with a capital letter and putting the quantity or variable in square brackets. Now that we have done some computations, if you look down the right-hand side of the screen, you will see a series of light blue brackets. These are called cells. Mathematica parses everything in a notebook into cells, grouping them according to its own internal algorithm. In future, we will see different types of cells, how to change cells, different functions, and formats that different types of cells have. The other thing to note is down the left-hand side, every input and output has been labeled with a number. These can be used as shortcuts instead of having to recompute some quantity. So if I wanted to know what 2 times 5/2 was from this previous output, I can just simply tell it, all right, give me 2 times the sixth output. Another handy shortcut is the use of the percent sign. The percent sign is used to use the last output. So, for example, the last output here is 5. If I wanted to add 2 to 5, I could indeed retype the 5, or I can just simply call it with a percent sign and it pulls the last output and uses that in its place. Now, most of these examples are very small and short, and so using these shortcuts doesn't seem to make a lot of sense, but when we're dealing with more complicated materials and more complicated computations, they save a lot of time.